Hello everyone, today we'll be going over and exploring software process models. So in our previous video we had mentioned different models of it, but in this video we will actually delve a little deeper and further into this and explain the process of these models and how they work. So software process models. So in this slide we have many different examples just basing off what different models are available. But aside from that, each one has a different way of working, and in this next slide we will see an example of one of these models and just like how the thought process is behind each one of these. Alright, so our slide is the waterfall model. So what is the waterfall model? Well, the waterfall model is a linear, plan-driven software process where development flows in one direction, almost like a waterfall. And it goes through a series of well-defined stages. So we have basically a sequential approach and phases of it. So first we have the requirements. This means that basically all system requirements are gathered and documented before any development begins. Next we have design. This means that a complete system architecture and design is created based on the requirements of it. Next we have implementation. This means that basically the developers will write the actual code based on the design and the documentation of it. Next, we have testing. So the system is thoroughly tested for bugs and to ensure that it meets the requirements. Next, we have maintenance. So it means that after release, the software is maintained through bug fixes and small updates, just progressively going. And so now we will also be discussing the limitations of the waterfall model. So a limitation of it is that it has poor flexibility. So it might be difficult to go back and change earlier stages once they have been completed. Next, we have late testing. So problems may only be discovered during testing, which can be costly to fix. And lastly, it may not be ideal for evolving requirements. So this may only work best only when requirements are stable from the start. Alright, so our next topic is about plan-driven and agile processes. So for plan-driven processes, it basically means that activities are planned in advance and that they follow a structured sequence, and they're usually best suited for projects with stable, well-understood requirements. And then the next one we have is agile processes, and this means that it uses incremental planning, allowing teams to adapt as the project evolves, and it will focus on flexibility, collaboration, and continuous feedback. And so some blended approaches is that in practice, many development processes combine elements of both, and that this can help balance the structure and adaptability depending on the project needs. Alright, so our next slide is about incremental development and how it works. So each increment delivers a partially complete but functional system, and each increment also provides core features, and later ones add more functionality based on feedback. This approach allows continuous improvement throughout the development process. And next is really the benefits of incremental development. So benefits can be the reduced cost of change. Since the system is built gradually, it's easier and cheaper to adjust the requirements or design during the process. Next we can have is early customer feedback. So when we're working with software and it's delivered early, the users can test it and provide input, helping ensure that the final product meets the real needs. We have a fast delivery of the value, meaning that the key features are delivered sooner, giving users something useful even before the full system is complete. Okay, so next we have integration and configuration. So what is it? So this approach builds software systems by integrating pre-existing components such as COTS, which is commercial off-the-shelf software, instead of developing everything from scratch. And components are selected based on the system needs. The development focuses on configuring, adapting, and connecting these components. Custom code is used only when needed to fill the gaps. The advantages can be that it has faster delivery, saves time by reusing ready-made solutions, it has a lower cost, buying components is often cheaper than developing new ones, it has greater reliability in the sense that the COTS components are typically tested and used by many others, but some disadvantages are that it has limited flexibility, compatibility issues, and dependency risks. Okay, so with that, we have reached the end of this video. I hope this video helped you understand just a little bit more of software process models and the different ones they have, and just exactly what revolves around these. Thanks for watching, and feel free to like, comment, share, and subscribe, and have a good one. Thanks.